The unseen hand probability in everyday life. From choosing a route with less traffic to deciding to take an umbrella based on the weather forecast, probability shapes our choices. Think about choosing what to wear in the morning. You might check the weather app. If there's a high chance of rain, you'll probably grab a jacket. That's probability in action. You're using information about the likelihood of rain to make a decision that affects your day. Probability isn't about knowing the future with absolute certainty. Instead, it's about understanding the chances of different outcomes and using that knowledge to make informed decisions. Understanding probability empowers us to make better choices and appreciate the intricate workings of the world around us. Flipping a coin. Understanding the basics. Let's start with a simple example. Flipping a coin. This everyday action is a perfect way to introduce the concept of probability. When you toss a fair coin, there are only two possible outcomes, heads or tails. Each side of the coin has an equal chance of landing face up. Each outcome has an equal chance of occurring, making the probability of getting heads 1/2 or 50%. Similarly, the probability of getting tails is also 1/2 or 50%. This simple act illustrates the core idea of probability, quantifying the likelihood of different events. Probability helps us understand and predict the chances of various outcomes in different scenarios. The probability of an event is always a number between 0 and 1, where 0 means the event is impossible and 1 means the event is certain. For example, the probability of the sun rising tomorrow is very close to 1. With enough flips, the results will tend to even out, with roughly half the tosses landing on heads and half on tails. This even distribution is a fundamental principle of probability, showing how outcomes balance over time. Understanding these basic principles lays the groundwork for exploring more complex applications of probability in various fields, from finance to weather forecasting and even sports analysis. Probability in finance, the Black-Scholes formula. Probability plays a pivotal role in finance, particularly in investments and risk management, guiding decisions and strategies. One of the most well-known examples is the Black-Scholes formula, used to price options accurately. This formula utilizes probability theory to estimate the likelihood of an option's underlying asset reaching a certain price by the expiration date. It essentially boils down to using probability to quantify the risk and potential reward associated with an option, enabling investors to make more informed and strategic decisions. Section 4. Quantum Physics, Probability at the Atomic Level. In quantum physics, probability reigns supreme. Unlike classical physics, quantum physics governs the subatomic realm, where particles like electrons and photons behave in ways that often defy common sense. One fundamental principle is Heisenberg's uncertainty principle, stating it's impossible to simultaneously know both the position and momentum of a particle with perfect accuracy. Instead of fixed trajectories, particles are described by wave functions, representing the probability of finding a particle at a particular location. This probabilistic nature means outcomes are not predetermined, but governed by chance. Schrödinger's equation describes how these wave functions evolve over time. By solving this equation, physicists can calculate the probabilities of different outcomes in quantum experiments. Section 5. Games of chance, poker, and the odds. Probability plays a crucial role in games of chance, adding excitement and unpredictability. In poker, this element of chance is what makes the game thrilling and challenging. Poker is a game where players must balance their understanding of probability with their ability to read opponents and manage risk. This delicate balance is what separates amateurs from professionals. Professional poker players constantly calculate the odds of making certain hands based on the cards they hold and the community cards on the table. They use this information to strategize their next move. They assess the probabilities of their opponents holding stronger or weaker hands, using this information to make calculated decisions about betting, raising or folding. This requires not only mathematical skill, but also psychological insight. Understanding pot odds, the ratio of potential winnings to the cost of calling a bet, is crucial in poker. It helps players decide whether a bet is worth the risk. Poker exemplifies how probability can be a powerful tool for analyzing and influencing situations. Mastering this aspect of the game can lead to consistent success and thrilling victories. Section 6. Probability in medicine. Diagnosing and treating diseases. Probability guides doctors in diagnosing diseases, assessing treatment options, and predicting patient outcomes. Medical professionals use probability to interpret test results and make informed decisions about patient care. Diagnostic tests are not always 100% accurate. Doctors use probability to interpret these test results, considering factors such as the test's sensitivity and specificity. Clinical trials rely heavily on statistical analysis and probability to determine if a treatment is statistically significant. Probability in medicine is about managing uncertainty to make the best possible decisions for patient care. Section 7. Exploring the universe, probability and dark matter. Astrophysicists use probability to study celestial objects, model cosmic events, and unravel the mysteries of the cosmos. By applying statistical methods, they can predict the behavior of stars, galaxies, and other celestial phenomena. Even when direct observation is challenging, one such mystery is dark matter, an elusive substance believed to make up a significant portion of the universe's mass. Despite its abundance, dark matter remains one of the most enigmatic components of the cosmos. Dark matter does not interact with light, making it invisible to telescopes. This invisibility poses a significant challenge for scientists trying to detect and study it directly. Its presence is inferred through its gravitational effects on visible matter, such as stars and galaxies. These gravitational influences cause distortions and movements that cannot be explained by visible matter alone. Scientists use probability to analyze these gravitational interactions and estimate the distribution and properties of dark matter. By creating complex models and simulations, they can better understand how dark matter shapes the universe. Observations have shown that galaxies rotate much faster than expected based on their visible mass alone, suggesting the presence of dark matter. This discrepancy has led to the hypothesis that dark matter provides the additional gravitational pull needed to account for these high rotation speeds. Probability serves as a crucial tool in our quest to comprehend the vastness and complexity of the universe. It allows scientists to make educated guesses and refine their theories about the unseen forces that govern the cosmos, bringing us closer to unlocking the secrets of dark matter and beyond.